The next big area of opportunity for cutting cost is what I called aggressive janitors. This was my term that I coined at Netflix. And it's really just making sure that um, across the board, we are just not being wasteful, right? It's easy to create a lot of data exhaust, a lot of waste in our data systems that we don't clean up, and that cost definitely compounds over time. And so aggressive janitors is the process of cleaning that stuff up. And the first area there is really uh, is discovering and cleaning up unused tables. So another phrase we had at Netflix for this kind of stuff was data dark matter. It was a bunch of data out there. Nobody was really sure if it was being used, who created it, why it was being used, does it have any value to the organization? And there's a lot of that floating around in our data warehouse. Um, and it has storage costs, obviously, but it has processing and operational costs as well because these tables were often being fed by processes, and there were whole, trees of tables and pipelines that were filling these things out, and dashboards that were being filled out every day that nobody was looking at. And there's just a lot of waste. And so, in order to get at these unused tables, like obviously, the first thing you need to do is have an understanding of what's being used. You need usage reporting, right? And that includes things all the way down to your dashboard. Right? It's a common meme that 100 dashboards get created and 99 of them don't get used. And that's sad from a hey, we did all this engineering work perspective, but they also don't get cleaned up. They just sit out there, and all the pipelines that are powering these dashboards often just get left on, and it was just a bunch of waste. So understanding what's being used, what's not being used, is the beginning of the problem, and then understanding the lineage, right? Because if a dashboard isn't being used, you want to be able to walk the chain back up to say like, well, which tables are powering that dashboard, and which pipelines are filling those tables up, and continue to walk that chain up, and so that you can remove large sections of processing and storage that aren't necessary for your business. Another sort of thing that we did at Netflix, which I had a really like positive impact, which maybe isn't obvious, but actually was a pretty major win for us, was user level scratch spaces. A lot of the work we do in data analysis, data science, we create a lot of temporary tables, experiments, one-off, ad hoc analyses to answer a question, and it's easy to just leave that stuff around. And so what we did was create spaces where our users could do that work, but by default, those tables had very aggressive TTLs. They would automatically be dropped within 30 days unless you went in and tagged them for keeping for longer, or move them into a production space because they became part of a production pipeline or production dashboard. And that was great. We got rid of a lot of that. It's one thing to go clean up unused tables, but you also have to stop the bleeding and prevent more of these unused tables from being created constantly. And having these aggressive table TTLs was a good win in that space. One of the big challenges with cleaning up unused tables is indecision, right? Like nobody wants to be that person who deletes a table that actually was being used. And so if you're not sure if a table is being used or not, the default behavior is often just like, well, we'll just leave it. And so Tabular has some things here that can really help you clean up with confidence, be more certain, and take action more aggressively. The first one is those usage level tables and access logs, right? So we talked about usage being a necessary piece of this puzzle, and tabular system tables provide really in-depth usage across like which tables are being used, which sections of which tables are being used, by whom, who's reading, who's writing, and who's authorizing access to these tables. All of that is provided, and you can build rich reporting off of that and decide which tables to go clean up. The other ones are things that they allow you to undo, right? So one of the big risks for dropping a table is that it can be very difficult to undo that action in a typical data warehouse, certainly in like a Hive style world. And so a couple of things here, you can use access controls as a mechanism for soft deleting. So, hey, I don't think this table is being used anymore, but I'm not quite sure. Let me just remove access. And if anybody screams, then it's easy to just restore access. We haven't lost anything. We can even just remove read access. Say keep the data flowing, keep writing to this table to make sure we don't lose anything. Turn off read access and see if anything breaks or anybody screams, and sort of more cautiously start to work our way up that chain. And the other thing is, if you do happen to drop a table that was really necessary, the Tabular platform, allows for a very simple one-click table restore, and everything is back the way that it was. So that's a nice feature that you get to give you more confidence to go for cleaning up these unused tables. The next piece of sort of this unused data space is unused data within tables. So maybe a table is being used, but it has a whole bunch of history that maybe isn't being used, right? And not surprisingly, what we see is that time series data in particular has a very steep value decay curve, right? As data ages out in a table, it becomes much less valuable and is used much less frequently. And that really depends on the data and the table. But certainly, after 3 months, 6 months, a year, we see steep declines in usage of time series data. And so, having a mechanism where you can set sort of record level TTLs in these types of time series tables is very valuable. Like, hey, after 3 months, we want to move this data into a cheaper storage tier. Most of these clouds offer multiple different storage tiers. In S3, you've got sort of the default storage tier, but you also have these infrequent access and other intelligent tiering systems, which are less expensive. And so if you're not going to, they're less expensive as long as you're not using the data, right? If you access those objects a lot, they can become more expensive. So the key is to figure out when to move the stuff into other tiers, and then eventually when to just purge it from the warehouse altogether. The other one that caught us at Netflix, that we actually had big wins on, which maybe wasn't super obvious, was columns that weren't being used. And this one was a little more difficult to unwind, but we had a number of tables where the bulk of the table is driven by one or two very large unstructured text columns. So you might have a large table, maybe it's a petabyte of data. This was common on Netflix, and 80% of that petabyte was really a single column that had a bunch of JSON that got dumped or something. But it turns out that either that column wasn't being used at all, or the vast majority of the queries were only pulling out little bits of that JSON. They weren't using the whole JSON payload. And so the answer here is to hey, why don't we turn that unstructured text or JSON? Let's just pull out those fields that people are using into top level columns that we can then compress and sort and structure, and as early as possible in our pipeline process, drop or not carry forward the big unstructured text columns. And that really helped take these petabyte style tables and reduce their size by 80% or something without losing any of the value of the data set. So definitely beware of those large unstructured text columns. In order to see that again, you need you need a breakdown of the size of the columns within your table, and that stuff is available in the Iceberg metadata. You can say for a given column how much of the total tables space is it using, as well as is anybody using that column level usage. So both of those are important pieces in order to take advantage of those kind of opportunities. And the last area that I'll talk about in terms of this sort of aggressive janitoring is cleaning up historical data in orphaned files. And this is actually an area where Iceberg introduces a problem, but also has some powerful tools for dealing with it. So one of the nice things about Iceberg tables is that you have this linear snapshot history over time, which means you can do time travel style queries. That's very powerful, but it also means that we have a bunch of historical data in our warehouse, which may or may not be accessible over time. And so here's an example, we've got these 8 snapshots in a table, and maybe these first 4 snapshots are what we call expired, meaning they are no longer queryable snapshots. They've been removed from the table metadata, but those files potentially are still out there on disk. And so we need a process where we go and look at the expired snapshots and see which files are no longer reachable and go ahead and clean those files up. In addition, In order to guarantee asset semantics, uh, Iceberg tables, you may have jobs that are writing data out, but never committed to the table. Maybe you had a Spark job and it was halfway through processing, and half of the tasks, finished writing their Parquet data, and then it was a failure. So those Parquet files got written into S3, but never actually got committed into the table. Now in Hive, this was a really big problem. We run into correctness issues where we had incomplete or inaccurate data. In Iceberg, we don't get that, right? Because those files are never committed to the table, so we don't have correctness issues. But potentially, we have these orphan files laying around out there in S3. So we need mechanisms by which we can go clean that stuff up. And Iceberg has procedures in open source to do these sorts of things. Obviously, the Tabular platform, we take care of this stuff for you. So we're automatically going to remove unused historical snapshots, clean up orphan files, and we have mechanisms to set these TTLs, right? You can set row level TTLs and table TTLs. Some of these other mechanisms we talked about for automatically just going through it and deleting old data, per policy. And this year we've got plans on the roadmap to handle that other piece, which is not only delete data, but also just move it into better storage tiers as we recognize, hey, data in this table isn't really queried after 6 months. Let's go ahead and take any data older than 6 months and move it into to a lesser tier and save some money.